Okay, write polar equations of conics, and we're given an eccentricity of 0.5 and vertices at the points -4, 0 and 12, 0. So what do we know? If we have an eccentricity that's greater than 0 and less than 1, that we know that our shape is going to be an ellipse. We're also given the vertices, which we know is on the x-axis because it's -4 and 0. So if we were to sketch these, so -4 would be here and 12 would be here. So here's our points, and our ellipse is going to look something like this. So the focus is at the center. We need to find the midpoint. So to find the midpoint, we can add our x coordinates and divide by 2, and the same with our y coordinates. So we're going to have the points of 4, 0. So 4, 0 is going to be our center. And what we need to do is to find D. So to find our directrix. So the vertex point. So we are going to look at r comma theta. So this is our equation. And if we look at the distance formula for polar coordinates, and we can work out that r is going to be 12, and then tan to the -1, and this is going to be y divided by x, which is going to be 0 divided by 12, which is 0. So that is going to give us points of 12, 0. So what do we know? So because the midpoint is over here, then we will have our directrix. So this is going towards our focus, and it means that our directrix is going to be over here to the left. So our equation ED is going to be 1 minus E cosine of theta. Now we know it's cosine because it's on the x. So we need to substitute in the values we know. So we have 0.5 times the directrix, which we need to calculate. 1 minus 0.5 cosine of our angle. Now our angle here is going to be 0. So we've worked out our angle here as 0. So cosine of 0 is going to be 1. So let's rewrite this again. So we have 0.5 times d, and this is going to be 1 minus 0.5 times 1. Now r we've worked out is going to be 12, so we can replace that. So this is going to be 12. And now if we just simplify, so 12 is equal to 0.5 d, and then we have 1 minus 0.5 is going to be 0.5. So our 0.5's cancel, and the directrix is 12. But it's negative, so this is going to be on the line y is equal to minus 12, which is going to be here. Right, let's write our equation. So what do we know? So r is equal to, the eccentricity is 0.5, the directrix is 12, and this is over 1 minus 0.5 cosine of theta. So it's going to be 6 divided by 1 minus 0.5 0.5 cosine theta. And if we check this, okay, so here's our graph in Desmos, and we can see we've got the point of -4 and the point of 12, and our directrix is here on -12. Okay, so a question for you to try. Write the polar equation for the conic with eccentricity of 0.2 and the vertices at -4, 0 and 6, 0. So pause the video, answer the question, and when you're ready for the answer, press play. Okay, let's have a look at the answer. So we know that E is greater than 0 and less than 1. So our conic is an ellipse. We're told that our vertices, so the vertices and these points, so our vertices are on the x-axis, so we know we're looking at cosine, and if we draw these, the focus is at the center. Now we need to find the midpoint. So the midpoint, if we add our x's, divide by 2, and then add our y's and divide by 2, we'll have the midpoint, or the center, will be at 1, 0. So this is going to be our center of our ellipse. Now, if the center is at this part, it means that it's opening in this direction. So our directrix is going to be to the left. So this is going to be a negative, but we don't know the value yet. So we're going to find using our r and theta, and we're going to look at the distance formula. So we're going to look at our coordinate at 6, 0. So we've got 6 plus 0. So r will be the root 36, which is just 6. And then to find theta, we want tan to the -1 of y over x, which is going to be 0 divided by 6, which is 0. So theta will be 0. So we have r theta will be 6 and 0. So now if we look at our equation, so we want to write E, D, and we said it's cosine, and it's going to be negative, so 1 minus E cosine theta. So we're going to substitute in the values that we know. So first of all, we know R is 6. We know that eccentricity is 0.2. We don't know the directrix. And then we have 1 minus 0.2 cosine of the angle. So it's cosine of 0, and cosine of 0 is 1. So this is just going to be 1. So we now just need to simplify. So 0.2, and then 1 minus 0.2 is going to be 0.8. So, okay, so our next step, we're going to multiply both sides by 0.8. So we will have 6, this will be 4.8 is equal to 0.2. So now we're going to divide both sides by 0.2. So they cancel. And D is going to be equal to 24. So because it's x, it means that it'll be minus x. So x is going to be minus 24. So now we need to put this into equation. So R is equal to E, so 0.2, the directrix is 24. And then we have 1 minus 0.2 cosine theta. So 0.2 times 24. So we're going to have a fraction. So what we're going to do is multiply, because 0.2 2, if we multiply this by 5 to make it 1, and we do the same with the bottom, multiply by 5. So this will be, okay, so that's multiplying everything on the top and everything on the bottom. So I'll have 0.5 will be 1, so on the top I'll just have 24. 5 times 1 is 5. 5 times minus 0.2 is minus 1. So that's just going to be minus cosine of theta. And this is our final answer. We'll just check the graph. Okay, so if you put our graph into Desmos, so we can see that we have an ellipse, and here is our directrix at minus 24.